Hey kid, you wanna do some math with me?
I don't know. Am I gonna get caught?
Nah man, I do it all the time at school.
I guess I could give it a try.
The surface area equation of a cone is pi times radius times slant height plus pi times radius squared. Since the slant height is not given to you, you must use the Pythagorean Theorem to find it. First, set 8 squared plus 15 squared equal to L squared. Then, multiply out the exponents. Your equation will be 64 plus 225 equals L squared. From there, simplify each side, and you will get the square root of 289 equals square root of L squared. After that, take the square root of each side. You will end up with L to be positive or negative 17. Since the length cannot be negative, L will equal positive 17. The second part of solving this problem is plugging in the correct values for the surface area equation. As previously mentioned, the surface area equation of a right cone is pi times radius times slant height plus pi times radius squared. Substitute in corresponding values, and you should be left with pi times 8 times 17 plus pi times 8 squared. Multiply the values, and your equation will now be 136 times pi plus 64 times pi. Simplify the equation by adding the like terms, and you will get the surface area to equal exactly 200 pi. The final step to finding the surface area of Jason's cone is to multiply out 200 pi. Your final answer, rounded to the nearest tenth of an inch, is approximately 628.3 square inches.
Yeah, man. Square the A, square the B.
Yes,
Yeah,
keep
parabolas,
squaring.
quadrans. Yeah?
Thanks for helping me do my math.
No, man. Thank you. Now I'm addicted to math.
Hey, brother. Let me see your hammer.
Do you even lift?
Brother, have you been working out?
Yes, I have. Thank you for noticing. But only the worthy can lift my hammer.
Brother, can you even tell me the volume and surface area of your hammer, as it is a composite figure?
It is?
Would you care to show me how to find the volume and surface area of my hammer?
Of course, brother. Let's get cracking down on it.
Yes, let's.
The key is finding the surface area of Thor's hammer. Since the hammer is a composite figure of two cylinders, we need to find the surface area of both, then add them together. The equation for surface area is 2 pi r h plus 2 pi r squared. If you put in the corresponding numbers, you get 2 pi times 1.25 times 6 plus 2 pi times 1.25 squared, and then you can simplify it to 15 pi plus 3.125 pi, and your exact answer is 18.125 pi square centimeters and approximately 56.9 square centimeters rounded to the nearest tenth. The surface area equation for the bottom cylinder is 2 pi r h plus pi r squared. Notice it's pi r squared this time because one of the bases is not visible. Now, you put the corresponding numbers in, and you get 2 pi times 0.5 times 15 plus pi times 0.5 squared. And then you simplify that to 15 pi plus 0.25 pi, and then you can get 15.25 pi square centimeters as your exact answer, and approximately 47.9 square centimeters to the nearest tenth. Now the composite surface area is both of the surface areas of each figure added together, and then you can get 56.9 plus 47.9, and approximately 104.8 square centimeters.
Brother, look, it's the frost giant. Get in position.
Hey guys, Rachel Ray here, and today we're going to be making some scrumptious treats, an angle food cake. But first, let's welcome our special guest, Guy Fieri.
Hey everybody, thank you for having me on the show.
The pleasure is mine, and let's get to the baking. Oh God, it looks like you don't have oven mitts. Here you go.
Thank you, Rachel. I will need these for baking.
Of course you will. Now, let's get down to the business part. Now, first, you're going to need to dump your angle food cake mix into the bowl, as I have already done. And then you need to pour 1.5 cups of water into the bowl. And now Guy is going to beat it on low for 30 seconds, and then on medium for 1 minute. Watch as he beats it. See, we're coming to an end here. And there we go. Next step, we'll have to find the volume of our pan.
For Rachel and Guy to find the volume of their pan, they need to use a simple equation, length times width times height. When they plug in their corresponding numbers, they get 13 times 9 times 2.25. Once simplified, they get the exact answer of 263.25 cubic inches.
That we know the volume of our pan, we can now pour the correct amount of batter into the pan. After that, bake the mixture for 45 minutes at 350 degrees Fahrenheit. Okay, you guys, our next step is going to be to put the cake into the oven. Watch out, it is hot. Now, all we have to do is wait for about 45 minutes for the cake to be done. Now Alright you guys, now the cake is done. So now we're going to take it out of the oven. Watch out, it might still be hot. And now you guys can enjoy your scrumptious angled food cake. Before you go, I want to give you a few tips on how to cut your angled food cake so it looks as good as it tastes. These fancy cuts are called cross sections.
Yes, indeed. A cross-section is the intersection of a 3D figure and a plane. Pretend that this knife is our plane, and this cake is our 3D figure. Now when we cut the 3D figure parallel to its bases, the cross-section will take the shape of the bases. But when the plane intersects the 3D figure without being parallel to the bases, the cross-section does not take the shape of the bases. For example, if we cut the cake perpendicular to the bases, the cross-section appears to be a rectangle.
Thank you for the wonderful explanation, guy. Now join us next week when we learn to make pie.
Boys, we have a serious case. A pyramid's been stolen.
What are the specifications of this missing pyramid?
The surface area of the missing hexagonal pyramid is approximately 739.8 square inches. The volume of the pyramid is approximately 1,316.2 cubic inches. The pyramid has slant height 16 inches and has a base edge length of 10 inches.
I have no serious idea how you did that. Care to show me?
To find the surface area of this hexagonal pyramid, we will first need to find the lateral area and base area. To find the lateral area of this hexagonal pyramid, we will need to use the equation number of sides times the quantity of 1/2 the base times the height. Substitute in the given values and you will have the equation 6 times the quantity of 1/2 times 10 times 16. Simplify what's in the parentheses and you will get 6 times 80. Your exact final answer for lateral area will be 480 square inches. Next, we need to find the base area of our hexagonal pyramid. The equation to find the base area of a pyramid is 1/2 times the apothem times the perimeter. Before we proceed in this equation, we will first need to find the length of the apothem of the pyramid. Since a hexagon is the only shape that can be divided into congruent triangles, you can make them into 30, 60, 90-degree triangles by drawing a perpendicular bisector from the center of the hexagon to the midpoint of an edge. This line is your apothem. Since the apothem is a perpendicular bisector of the edge, use the first to divide the base edge length by 2. Each segment should now be 5 inches. Now to find the apothem, since it is a 30, 60, 90-degree special right triangle, we just need to multiply half of the edge length by the square root of 3. As a result, the length of the apothem is equal to 5 times the square root of 3. Now plug the values back into the equation for base area and we will get 1/2 times 5 root 3 times 60. Multiply the values and we will get our exact answer of 150 times the square root of 3 square inches. After finding both the lateral area and the base area, we can combine them to get the surface area. So add 480 and 150 root 3, and you will get approximately 739.8 square inches. For the next step, we will be finding the volume of our hexagonal pyramid. To do so, we will be using the equation 1/3 times the base area times the height. Some may be saying, wait, but we don't know the height, and that is true. But since the altitude of our pyramid, the apothem, and the slant height all form a right triangle, we can use the Pythagorean Theorem to find the height. Substitute our values. Here's our apothem, 5 root 3 squared, plus the height squared equals the slant height squared, or 16 squared. Multiply on both sides and you will get 75 plus h squared equals 256. Subtract 75 from both sides and take the square root of both sides to get the square root of h squared to equal the square root of 181. You will get the height to then equal approximately 13.5 inches. Now that we know the value of our height, we can plug that value back into our volume equation, which again is 1/3 times the base area times the height. Plug in the corresponding values and you'll get the volume to equal approximately 1/3 times 150 root 3 times 13.5 to then equal a final answer of approximately 1,169.1 cubic inches.
Thanks for teaching me, guys, but I've been thinking this case sounds like, a lot of work, so maybe we should just, ditch the case. If you know what I mean.